Okay, this is the lecture video on the intermediate value theorem, and we're going to prove that this exists. We're going to let I be an interval and let our function be an interval that tends towards all real numbers, be continuous on interval I if A and B are within this interval, and if K is an element R, satisfies that f of A is less than K and is less than f of B. So in other words, we've got this point C that is going to produce K. So we're saying that f of C equals 2K. So this point here, this will be, if this is A, then this point here, this is f of A. And if this is B, then this point here is f of B. So we're saying that if A and B are interval I, are within the interval, and if K is an element, is an all real number, satisfies that K is going to be larger than f of A. Here's K, here's f of A, so K is larger than f of A, but K is less than f of B. Then, so K is in between f of A and f of B. Then there exists a point C, here's our point C, within our interval between A and B, such that f of C is going to equal to K, and we want to prove that. So we start off with, we want to say, suppose A is less than B, and we want to let let g of x equal to f of x minus k. So we're creating this relation, this function, to where we're establishing a relationship between our function f and k, where f of A and f of B is in relation to k, and so we're calling that g. Okay, and this we're going to call this equation I. Okay, so we're going to refer back to that. So we can say that g of A is equal to f of A minus k. And we can also say g of B is equal to f of B minus k. Okay, now we want to keep in mind that f of A, we want to keep in mind that f of A is less than k, and that's less than f of B. So we can say that k, we can say that k is larger than f of A, which on the graph it obviously shows that k is larger than f of A. Then we're saying if k is larger than f of A, then we can say that g of A is equal to f of a minus k. Since k is larger, then that's going to be less than 0 or negative. Okay, so because f of a is smaller than k, we're going to get g of a is going to be less than 0. So since k is less than f of b, then g of b is f of b minus k. So now f of b is larger than k. So now we're saying that g of b is positive, greater than 0. All right, so then we can say, so in that case, we can say that thus we can say that g of a is less than 0, and 0 is less than g of b. Okay, so from here we can apply the location of roots. Location of roots theorem, or LRT, location of roots theorem. And so from here, let, in this location of roots theorem, we're saying let our interval between a and b be an interval, and let our function be continuous on the interval, and all real numbers be continuous on our interval I. So from here, if f of a is less than 0 and 0 is less than f of b, or if f of a is greater than 0, or is greater than 0 is greater than f of b, then there exists a point C that's an element within our interval AV, such that f of C equals 0. In other words, we find a root. So when f of a is less than f of b, we have a function that looks like this, that's going up. When f of a is greater than 0, then it's basically going the other way. Now here's a, and here's f of a, and here's b, and here's f of b. And here's k. but when they say it's equal to 0, then they're talking about it being on the x-axis. Okay, so from here, we're saying that as g of a is less than 0 and 0 is less than g of b, then there exists point C where A is less than C, which is less than B. So A is less than C and C is less than B. And such that G of C equals 0. And we're going to call that equation II. So we have equation, so now we have equation I is g of x equal to f of x minus k, and now we have equation II where gc equals to 0. All right, so from here, we can say, but by equation 1, by our equation I, we said that g of x equal to f of x minus k, and we said that II is gc equal to 0. So we can say that g of c, so if we substituted c in, right, we get g of c is equal to f of c minus k. And so since we said that g of c equals 0, we can substitute 0 in for g of c. So that's going to be 0 equals to f of c minus k, or we can just say f of c minus k equals 0, and then if we apply plus k to both sides, we get f of c equals to k. So you can also, basically you would do the same thing as if A were larger than B and work the same process. So from that, we've proven our intermediate value theorem, and that concludes this video.